radical expressions and equations. When we talk about radical expressions, we're basically talking about root equations, square roots, such as 9 times 9 is 81. The square root of 81 is 9. Now we're going to be talking about principal roots because theoretically, negative 9 times negative 9 is also 81. But for our discussion today, we're going to talk about the principal roots, not the negative roots. So we've got some examples here. The root function, square root of 25, equals 5 because the inverse has 5 times 5, which is 25. And if we don't see a number by the little root symbol over here, we assume it's a square root. In other words, we could put a 2 here, but we don't. That just means it's something by itself twice. Square root of x squared is x, because x times x squared. Now this one's a little tricky, but not really. This negative is on the outside, the same as a negative 1. So it's negative square root of 25. Square root of 25 is 5, but it's negative on the outside, so it'll be negative 5. Now there's a cube root. That means something by itself 3 times. The cube root of 8 is 2, because 2 times 2 times 2, and is 8. And you see there's 1, 2, 3 here. 3 of the same numbers, and that's what that means, that root. The other thing we can do, we can multiply these separate components. Negative x squared times the cube root of 8. Well, the square root of negative square root of x squared is x. And then the cube root of 8 is 2. But there's a negative on this outside here, so that makes it negative 2x. And then we got, that should be the fifth root right there, not the square root, because there's 1, 2, 3, 4, 5 2s. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And that, the fifth root of 32 is 2. Now here's some examples. Your square root of 225 is simply 15. 15 times 15 is 225. Square root of 25x squared, square root of 25 is 5. Square root of x squared is x. Square root of the binomial function 2 minus x squared. Well, that's simply 2 minus x. Take everything outside the square root of that. Now this one looks hard, but it really isn't. This is x squared plus 12x plus 36. I'm going to write this as a couple of binomial equations that we'd factor. X plus 6 times x plus 6, we use FOIL x squared plus 12x plus 36. And this can be rewritten as x plus 6 squared. Well, the square root of something squared is itself. So it's simply x plus 6. Simplifying radical expressions. If we have the same base here, and the base here is 2, you don't see anything, so you know it's a 2. So this is base 2 here, and this is base 2 here, because we don't see anything. Same thing, 3 times square root of 3 times square root of 5, same base, square root of 15. And we assume there's a 2 there. Square root of 5a has 2b, 5 times 2 is 10, and a times b is ab, so it's 10ab. Unit fractions, square root of x over 4 times square root of 7 over y. X times 7 is 7x. And 4 times y is 4y. And square root of 7x over 4y. Example 4 is a little tricky. You got to be careful though. Square root of 80 over square root of 5. Well, 80 over 5, it's the same base here. I know if I don't see anything, as I said, I assume it's the square root. 80 divided by 5 is 16. Square root of 16 is 4. Now let's simplify some of these. Here's a similar example. Square root of 15 times square root of 6. 15 times 6 is 90, so square root of 90. But square root of 90, I can rewrite as the square root of 9 times the square root of 10. And square root of 9 is 3. I can't do anything in square root of 10, so it's 3 times square root of 10. Example 2. 5a to the 7th. Square root of that times 15a to the 3rd. 5 times 15 is 75. A to the 3rd, a to the 7th times a to the 3rd is a to the 10th. Remember, we have the same base, we add the exponents. That's 75a to the 10th. And I can simplify this. That's equals 25a to the 10th, which is 5a. 25a to the 10th is 5a to the 5th. Square root of 25a to the 10th is 5a to the 5th. And left of the 5a is 25 times 5 is 75 times square root of 5. And square root of 121 over x squared. Square root of 121 is 11. Square root of x squared is x. Now, we can also add addition subtraction of radicals. Let's look at the first example. I don't know why there's a u there. We're going to erase that as best I can. 6 times square root of 7 plus 4 times square root of 7 is 10 minus square root of 7. We've got to have this not only the same radical, and this is, like I said, we don't see anything as it's a square root, but it's also got a 7 for the base inside. We can use FOIL to solve binomial equations with radicals. If I'm multiplying 4 times square root of 3 plus square root of 2 times square root of 3 times minus 5 square root of 2. Let's do the outside first. 4 times square root of 3 times 3 is, square root of 3 times square root of 3 is 3. That's square root of 9. Square root of 9 is 3. It's 4 times 3. The inside, that would be, the outside first. 4 times 5 times square root of 3 times square root of 2 is 20 square root of 6. Then the inside, square root of 2 times square root of 3 is square root of 6. And then the end is square root of 2 times 5 times square root of 2. And that is 5 times 2, because square root of 2 times square root of 2 is simply 2. So I'm left with 4 times 3, which is 12, down here. And then 20 square root of 6 plus square root of 6, negative 20 square root of 6 minus 19 square root of 6. And then minus 5 times 2, which is minus 10. 12 minus 10 is 2. And I'm left with minus 19 square root of 6. And that's our answer. Here's another one. If I got square root of 3 plus x squared, if I use FOIL, that's simply square root of 3 plus x, that's 3 plus x. Square root of 3 times square root of 3 is 3. That's square root of 9, which is 3. Square root of 3 times x is x times square root of 3. X times square root of 3, that's x square root of 3. And that x square root of 3 plus x square root of 3 is 2x square root of 3. And then x times x is x squared. So my final answer is 3 plus 2x times square root of 3 plus x squared. Let's look at some problems here. 2 times square root of 3 plus 9 square root of 3 got the same base on the inside as both the square root. So 2 square root of 3 plus 9 square root of 3 is 11 square root of 3. Second one here, we're multiplying it out. Square root of 6 times the binomial 2 plus square root of 6. Square root of 6 times 2 is simply 2 square root of 6. Square root of 6 times square root of 6 is square root of 36, which I said is 6. So my final answer is 2 square root of 6 plus 6. Now, if you look at this last one here, you can see this is a difference of squares. It's 4 minus square root of 3, 4 plus square root of 3. We use FOIL. 4 times 4 is 16. Do the outside, 4 times square root of 3 is 4 square root of 3. And then the inside, 4 times negative square root of 3. And these two end up canceling out. And then negative square root of 3 plus square root of 3 is minus square root of 9, which is 3. So it's 16 minus 3, 16 for this first part. The middle parts cancel out. And this is minus square root of 9, which is 3. 16 minus 3 is 13. Final answer of all that, 13. Now, another thing we can do is we can solve radical equations. Let's look square root of x minus 3 equals 4. We're going to do the same we did in the first couple lessons. We're going to balance the equation. Except instead of add, subtracting, or finding the reciprocal, we're going to square it. Square root of x minus 3 equals 4. Let's get rid of that 3. So I'm going to add 3 to both sides. I got square root of x equals 7. If I square both sides, square root of x squared is x. Add 7 squared is 49. So x is 49. Now on this side here, let's look at this. I got x minus 7 equals 2 times times square root of x plus 1. If I square all that on both sides, 7 minus x squared, that's a perfect square trinomial. It's x squared minus 14x plus 49. And then 2 times square root of x plus 7. Everything squared there is 2 squared is 4, x plus 1. Square root of x plus 1 is x plus 1. So that would be actually 4x plus 4 here. That's all I've done when I square that. So I get an equation on the left here, x squared minus 4x minus 49, that's 7 minus x squared, equals 4x plus 4. And I start moving stuff around here. I move that minus 4x on this side from here, and that leaves me minus 18x. And then I move that minus 4 from this side. Let me see here. Plus 4. I subtract 4. 4 from 49 is 45. So I get left with x squared minus 18x is 45. Which, if you use the PQ method, is x minus 3 times x minus 15. Square root of 5x plus 2 is 7. It's got numbers on one side and the radicals on the other. So subtract that 2 from both sides. Square root of 5x equals 5. Square both sides, and 5x equals 25. Divide both sides by 5, and I get x equals 5. This last one here looks a little hairy, but it really is really very simple. Square root of 5x minus 3 equals square root of 2x plus 3. I'm going to square both sides, and I'm simply left with 5x minus 3 over 2x plus 3. I'm going to get rid of that 3 first by adding 3 to both sides. So I'm left with 5x equals 2x plus 6. Then I'm going to get rid of that nice 2x on the other side. 5x minus 2x is 3x. 3x equals 6. Divide both sides by 3. And I get 3x over 3 equals 6 over 3. And I get x equals 3. Whoa, nope. X equals 2. Yeah, 6 over 3 is 2, so that would be 2. Now, the last thing I want to talk about is complex numbers. This is used in like retrogressing a lot of data, looking at where previous things started. And if you have a square, 2 times 2 is 4. Negative 2 times negative 2 is also 4. So there's no way you could have a negative square root on the inside. But to do this retrogressive analysis, to go back in time to find out what was going on past, we use the square root of negative 1. And we call that I. Square root of negative 1 is I. And the square root of negative 1 times square root of negative 1 is I squared. And square root of negative 1 times square root of negative 1 is negative 1. So I squared is negative 1. But it's no different in radicals. Radicals. No different in variables or adding whole numbers. Let's look at this right here. 8 plus 6i plus 3 plus 2i. 8 plus 3 is 11. 6i plus 2i, we do the same thing. It's 8i. So my lines are 11 plus 8i. We multiply I, we get I squared. And remember, if I squared negative 1, then I squared is square root of negative 1 times square root of negative 1, which is negative 1. Negative 2i times 5i is negative 10. Negative 2 times negative 5 is negative 2 times 5 is negative 10. I times I is I squared. Remember, I said I squared is negative 1. We're just replacing that. So it'd be negative 10 times negative 1, which is 10. We've got a more complicated solution, but we can see if this is a solution. If x equals 1 plus I. And every time I see an x, I'm going to put 1 plus I here. X squared minus 2x plus 2. So I put x plus I squared minus 2x over 1 plus I. And 1 plus I squared is 1 plus 2i plus I squared minus 2 times 2i plus 2. And remember, I squared is negative 1. So 1 plus 2i minus 1. The 1 and the minus 1 cancel out right there. Minus 2 plus 2i. Well, there's a plus 2i right there, and that cancels that. Negative 2i. And negative 2 plus 2 is 0. So this whole thing is a correct solution. Now let's do some simple writing here of these problems. Square root of negative 36. I'm going to write that. That's the same as square root of 36 times square root of negative 1. And remember, square root of 36 is 6. Square root of negative 1 we call I. So add these here. Negative 4 plus 5i plus 7 plus 3i. Negative 4 plus 7. I multiplied this here. And I meant to do this. Let's look at that. We're going to go all the way through with this. That should be multiplying. Negative 4 times 7 is negative 28. Negative 4 on the outside, negative 4 times 3i is negative 12i. 5 times 7i is 35i. And then on the last, negative 5i times 3i is 15i squared. So I got negative 28 minus 12i plus 35i is 23i. And then 15i squared, which is 15 times minus 1, which is minus 15. So minus 20 minus 15 is minus 43. And 23i remains the same. Final answer, minus 43 plus 23i. And then I've got negative square root of 16 times negative square root of 64. Well, let's see if we can factor this out. Negative square root of 16 is the same as 16 times negative 1. Negative 64 is 64 times negative 1. Square root of 16 is 4. Negative 1 is I. 64, square root of 64 is 8. And here's another I. Negative 1 is I. So 4 times 8 is 32, right here. And then I times I is I squared. And I squared, as I said before, is square root of negative 1 times square root of negative 1, or just negative 1. So 32 times negative 1, 32 times I squared, 32 times negative 1 is just negative 32.